In this video, we are going to talk about rapid changing dimensions, and for that, let's quickly understand slowly changing dimensions and SCD type 2 with this simple example. Here we are maintaining the details of employees and the team they are part of. We got a row for John. He became a part of Team Blazers on 1st January 2021. So we have kept this row as active in our OLAP system and we have set the end date as null. Now whenever the employee moves to a different team, we will add another row to our target table with the new values and we will update the previous row to inactive. Also, we will update the end date to a date 1 day prior to the date of the change. Now with this, we are able to maintain the history of changes to our rows or dimension whenever an attribute of the row is changing. This representation that we just saw in this example is also referred to as SCD2. Here we maintain all history by inserting a new row every time an attribute changes in our base dataset. Now, as the name suggests, usually our dimension change at a slow pace, and for that, this approach works perfectly and we are able to maintain historical data easily. But in specific scenarios, the attributes of a dimension change rapidly, like foreign exchange rates and some other financial instruments. In those cases, if we choose to maintain history using SCD2, our dimension table size will increase rapidly, causing serious performance issues for our data model. To address such cases, we usually break our dimension table by separating the attributes which change frequently from the attributes which do not change often. In this way, we can handle the size of our table and the performance issues. Let's understand this with a simple product table example for an e-commerce website which lists over 1 million products. On January 1st, 2021, you listed the products with their price, the discount offered on those products, and the commission the website is charging to list those products. The same was inserted in your dimension table in your OLAP system, and this table had 4 additional columns to maintain history using SCD2. The unique surrogate key, which is the primary key of this table, the start date and end date, and the active flag to show which record is active. Now after a week, on 8th January 2021, the discounts were revised as a part of the sale. Since an attribute in our source table has changed, we will have to add a new row to our table in order to maintain history. Now imagine how frequently these attributes change, and maintaining the entire history for 1 million records will soon become unsustainable in this format. Also, for the sake of simplicity and explanation, I have taken limited columns. Imagine a real project dimension table which has a lot of columns, and out of those, a couple of attributes are changing on a regular basis. It will become a nightmare to handle such scenarios during our reporting and dashboarding. This scenario, where some of the attributes of a table or dataset is changed frequently, is referred to as rapidly changing dimensions, and we can handle them easily by separating the attributes that do not change from the attributes that change frequently. We will create a separate table for both, and we will link the two tables using another table which is referred as mini dimension. And these tables will look like this. The first table will contain attributes that do not change often, if at all. It will contain the million rows for our million products. The third table will list the attribute that change often with the surrogate key, and the table joining the two dataset will contain the surrogate key and the natural key of the dataset along with the start and end date, signifying the durations when that particular record or surrogate key was active. Now for most of our analysis, the first table with attributes that do not change often should be sufficient for our reporting and dashboarding purposes. At the same time, this normalization of our dimension table will ensure that our dimension table size is kept in check. I hope this clarifies all your doubts related to rapidly changing dimensions or fast changing dimensions in data warehouse. In case if you still have any questions around it, please drop them in the comment section and I'll be happy to help.